Welcome to clickmeproject.com. Let's discuss the project about an information preserving watermarking scheme for right protection of EMR systems. In this paper, they propose a novel right protection scheme that will establish the ownership of EMR data. They propose the concept of information preserving watermarking. The basic motivation behind this technique is to first develop a model that determines the correlation of different features with the diagnosis. Model the process of computing a suitable watermark as a constrained optimization problem. Once the watermark is computed, is it inserted by utilizing the knowledge of correlation of those features that have negligible impact on the diagnosis. In our proposed work, we propose an efficient copyright protection scheme. First, we apply the discrete cosine transform to the host image and use the zigzag space filling curve for the DCT coefficients. The DCT coefficients in the zigzag manner are then mapped into 4 areas with different frequencies in a rectangular shape. Then we apply the singular value decomposition operation to each area, and the host image is modified by the left singular vectors and the singular values of the DCT transformed watermark to embed the watermark image. The left singular vector and singular values are used as a control parameter to avoid the false positive problem. Each area decides the scale factors optimal value use a genetic algorithm with a mean of a watermark SPs. A scaling factor is simulated by chromosomes and several optimization G operators are used. After remapping each modified coefficient DCT back to the original position, the proposed inverse DCT produces the watermarking image. This is the flow of our process. First, we apply the discrete cosine transform to the host image and use the zigzag space filling curve for the DCT coefficient. The DCT coefficients in the zigzag manner are then mapped into 4 areas with shape frequency in a rectangular shape. Then we apply the singular value decomposition operation in each area, and the host image is modified by the left singular vectors and the singular values of the DCT transformed watermark to embed the watermarked image. The left singular vectors and singular value are used as a control parameter to avoid the false positive problem. Each area decides scaling factor optimal value using the genetic algorithm with the mean of watermark species. Finally, we got the watermarked image. Then we will go for our extraction process. This is our flow of our process. First, we apply the discrete cosine transform to the host image and using the zigzag space filling curve for the DCT coefficient. The DCT coefficient in the zigzag manner are then mapped into 4 areas with different frequencies in a rectangular shape. Then we apply the singular value decomposition operation to each area, and the host image is modified by the left singular vectors and the singular values of the DCT transformed watermark to embedded the watermarked image. The left singular vectors and the singular values are used as a control parameters to avoid the false positive problem. Each area decides the scaling factor optimal value using the genetic algorithm with the mean of the watermarked species. A scaling factor is simulated by chromosomes and several optimization Z operators are used. After remapping each modified coefficient DCT back to the original position, the proposed inverse DCT produces the watermarked image. Next, we will go for our extraction process. In the first step of the extraction process, we apply DCT to the watermarked image. Second, we scan the DCT coefficient into 4 areas in a zigzag manner, and we perform the SPT operation for each area obtained from a zigzag manner, and then we subtract the possible distorted watermarked image in each area with the original transformed areas, and we obtain the distorted principal component for each area, and then we construct the DCT coefficient for 4 visual watermarks. Then we will apply the IDCT, inverse discrete cosine transform, to 4 visual watermarks. Then we will got the watermark image. Now let us see the execution of the process. First we select a find.m file and click run file. This open dialog box. First we have to select our watermark image. This is our watermarked image. And then we will select our host image. This is our host image. This is our original image. We have to resize our original image to 256 cross 256, and then this is our host image. The host image, the watermarked image, to be embedded 4 times in our host image. So we will resize our host image to 256 cross 1026. Sorry, 1056. 1024, and then we will apply SVD and DCT for. First we apply the DCT for the host image and apply SVD to our host image, and then we will apply our watermarked image to DCT and SVD. Finally we perform the optimization process using GA to find the optimization scaling factor of the watermark image for the DCT and SVD technique. Finally, from the optimized value, we will embed our host image. We will embed our watermark image to our host image, and then the reverse process is we will go for. This is our watermarked image, and then we will go for watermark extraction. Here we will done the reverse process of the watermark embedding. Here also we are applying DCT and SVD, and finally we go apply inverse DCT. Then we got our extracted watermarking. PSNR and MSE value. The total PSNR means a peak signal noise ratio, and MSE value are finded and displayed here. The performance of the proposed scheme is robust under different kinds of attacks, and the quality of extracted watermark is relatively good compared to existing approaches. Then our proposed algorithm works properly. Thank you.